So in class 19 is the last piece of paper, last in-class paper that's in your orange packet. So even though we're done with standard 4, this is actually standard 6. And this is one of the standards that we are skipping over and not going to assess on, but we still do need the basic information. So the first thing we're going to talk about is we're going to talk about rigid motion and then how that rigid motion can create a congruent polygon. We're going to do this in 2 days. So I'm going to go ahead and do the full lesson in this video, but it is a 2-day lesson. So if you need to skip ahead because you're just looking for the second half, you can do that. So the first part is to list the different transformations. So we have translation, we have reflection, we have rotation, and we have dilation. So those are the 4 from standard 4 that we actually did. We did the translation, we did a reflection, rotation, and a dilation. So rigid motion is any one of these things that preserves segment length and angle measure. So the one that doesn't do that, so segment length is just, it's the same size. The angles are going to be the same size. So the only one that doesn't do that is actually dilation. Dilation does not preserve the size. It makes it bigger or smaller. So it doesn't count as rigid motion. When rigid motion occurs, what we get is 2 what we call congruent figures. So congruent figures are the result of a rigid motion with the same shape, the same size, the same segment length, and same angle measures. So that's what congruent means. Congruent means it looks the same, and when you measure it out, it actually is the same on all parts, the angles and the sides. So congruent, I'm going to put this right above here. There's a special symbol for congruent that you're going to see today, and you're going to see a lot in standard 7. So we need to know what this symbol means. That symbol means congruent. And there are 2 parts to this. There's an equal sign, which yes, that means I have equal segment lengths, equal angle measures. But the part at the top, this little tilde right here, means that the shape is the same. So basically this means same shape, same size. So you'll see that down here. Triangle ABCD is congruent to triangle HGF. So these 2 are congruent. Can you show they're congruent by picking a rigid motion that maps one triangle onto the other? So which rigid motion are you seeing over here on the right? Well, we're seeing a reflection, and this is how we describe it. So we're seeing a reflection, and then we have to say over. Okay, so if we don't know how to describe a reflection, that comes into play here, and it's going to kind of be a deterrent moving forward and making sure that you know how to prove congruent figures. One way to do that is using rigid motion. So we're reflecting it over a specific line. And like we talked about at the beginning of class, that line is right in the middle here. So what you do to find that line is you count the boxes in between corresponding angles. So F and C, I count those boxes. I could also do H and A. You could count those boxes as well. But there are 2 boxes here, so we split the difference. So if there's 2 boxes, you go 1 over and draw that line. That is our line. Because that line goes up and down, that is an X equals line. Now you should now have this in 3 or 4 different pieces of paper on this packet. But if you don't, write it down again, because when we take our assessment on Thursday, sorry, we don't have school Friday, on Thursday of this week, you need to know that X equals is an up and down line and that Y equals is a right to left horizontal line. So X equals what? Well, this is -1. That's where it's at on the X axis. So -1. What statement can we make as a result of this congruence. Because I know that there is a rigid motion that maps these two triangles onto one another, I can say that the figures have the same shape and size. Or I can say that their segment lengths and their angle measures are the same. And that one's going to be the more important one. I can say the figures have equal segment lengths and angle measures. Okay, and that means the corresponding ones. And so we're going to talk about the key ideas here, but the word corresponding is also going to come up and to like, what does that mean? What does corresponding mean? Okay. So, summary. You can show that polygons are congruent. We're going to spend an entire unit proving triangles congruent. So you can show that polygons are congruent if you can describe a rigid motion that maps one to the other, or you can show that all pairs of corresponding parts are equal. Okay, so what's a corresponding part? Well, a corresponding part is when the pre-image or image pairs of sides or angles are congruent. Okay, and we're going to show how you do that below. So here's an example below. These sets can be read from the, okay, so I'm going to put this up here one more time here, that symbol. These can be read from the Congruent Statement. So we're going to do this. This is the congruence statement. We're going to write that down. What's a congruence statement? This is. So congruent statement is simply a statement of congruence. Okay? And so how are we going to find the congruent parts in here? We are going to, that's what this word is for, we are going to match so the first letter and the first letter here go together. So when I list out my corresponding angles, angle A would go with angle W. Angle B would go with angle X. Angle C goes with angle Y, and angle D goes with angle Z. If you need a visual for that, if you look up here in this congruence statement, angle A was up here. That goes with the first letter over here, which is angle H, which is over here. B is this one on the far side. That matches up with G, which those are the same. And then C goes with F. So that's a visual to go with this. This one just doesn't have a visual, but we're practicing just reading it from the congruence statement. Okay, so angle A goes with angle W. Angle B goes with angle X. Angle C goes with angle Y. And angle D goes with angle Z. Okay, then you have to do the sides. Well, sides have two letters, so you're going to read the first two letters here, and it's going to go with the first two letters here. So we'll go AB goes with, and then WX. Then do the next two letters. So then BC goes with the next two letters over here, XY. Then CD goes with over here, YZ. and then the last one. So I've kind of worked my way all the way across that statement. So now I'm going to go A and D. Those are the only two I haven't matched together. So A and D. So since there's 4 letters, there's going to be 4 angles, and there's going to be 4 sets of sides. So we need to make sure we have 4 congruent statements, 4 angles, and 4 for sides. So I did A with D for the last segment, and then WZ would also go together. Okay. Okay, moving on. So that was day 1. So day 2. Okay, so this is notation for measurement for when you're using the word equals. So I just want to be clear, we just did congruent segments. So congruent segments have bars over the top and congruency symbol in the middle. So an example is what you see above. So you would see AB bar congruent to WX bar. Okay. Now that means something different than the measurement of. So the measurement of, if you are using an equal sign in between, there is no bar and an equal sign. And there is a difference, and you will be knocked for not knowing the difference when we write our proofs with our congruent statements. Okay, so an example would be AB is equal to WX. So what you're saying here is you're saying that their measures are the same, but this could be a length on a rectangle, and this could be the length on a triangle. So it doesn't necessarily mean that they are the same thing. It just means that their lengths are the same. This means that they are both visually and numerically the same thing. And then if you're doing angle measurements, you will have a little m. Don't forget that little m for measure of, and an equal sign. So measure of angle A is equal to the measure of angle W from above. And here you have no M and a congruency symbol. So it would be angle A is congruent to angle W. And I know that that's such a small thing, but we are going to be specific about it when we move forward. So we're going to be specific about it now. All right, flip the page. Okay, so it's important to note that the drawings are not always done to scale. That means that objects may be congruent when they do not look like it. Trust labeled measures and congruent tick marks. Objects may not be congruent when they look like they are. From this point on, never measure angles or lengths with protractors or rulers. Okay, instead, rely on the information that you are given based on labels, congruency tick marks, arc marks, definitions, and theorems. Okay, now we're actually going to do some problems. So when we actually do our problems here, we are going to use this triangle, and we're going to try to see if they are congruent, yes or no. It says circle whether the pairs of polygons are congruent, explain why or why not. So what you're looking for are all of the sides congruent and all of the angles congruent. So we have 1, 1, we have 2, we have 2, we have 3, we have 3. Tick marks, yes. Then we have a 90, a 40, and a 50. A 90, a 40, and a 50. So yes, because all sides and angles are congruent to each other. Okay, so the congruency statement, triangle. Go ahead and pick the letters in whatever order you fancy, P, Q, R for the first one, but then when you go to write the second one, they must match up. So P is the 50-degree angle on this triangle, so we go to the 50-degree angle on this triangle, angle C. And then Q was our 40-degree angle, so that is B in the next triangle, and then D. Are these two triangles congruent? They are both, polygons. They are both rectangles, but I have a 4x8 rectangle here, and I have a 4x7 rectangle here. No, the sides are not congruent to each other. No congruency statement necessary. Okay, so the rest of it is just going to be some matching up. So I will do a couple here, and then I will let you try these, and then you'll head back to the second video that's printed to see the answers here. Okay, so this one says measure of angle F. So I actually want the number. So the number for angle F, it is not marked here, but I can find it by doing 180 minus 65 minus 40. So that's 105. So that makes this 75. It doesn't appear to be 75, but that's okay. So 75 is the measure of angle F. Okay, but down here it says angle F is congruent to. This is not a measure. This is not a number. Okay, it's asking what it's congruent to in the other triangle. If you're not sure, look up here. F is the middle letter. R is the middle letter. So this is angle R. Okay, let's do a side length. Here is a side length with no bar over the top. So I'm asking for RQ. What is that length? I want a number here. I want an actual number. Well, RQ, QR, goes with AF or FA, which is 13. So I'm going to put 13 here. That's actually a number. This one is not a number. Okay, so I'm going to go ahead and put in what segment AH is congruent to on the other triangle. If you look at the congruency statement, AH goes with QN. Okay, so give that a try, and then there's a second video to kind of finish off the last little bit of this note so you can kind of check and see how you did.